Okay, I'm going to move my mug since this is like the second day we're doing this, and we've gotten two lectures done, July 16 and 17. The slides are a little jumbled, but I mean, but they follow. In other words, I've got some repeat slides as we go through the days. So you got chapters 24 and 27. So basically we're covering chapters 24, 25, 26, and 27. It sounds like a lot, and it is, but it's not too bad. I'm cutting out thin film interference, which shows up in chapter 27 here. I mean, 24 was pretty simple. That was just the C equals lambda times F. That was pretty straightforward. And now we're going to do some problems with. Now we're going to start chapter 26. I'm starting to get brain dead. It's 3:40 in the afternoon. I'm starting to get brain dead here. And I'm going to quit here in about 20 minutes and finish this tomorrow on Friday. And I appreciate you all being troopers in tolerating this way to end actually in the course. And I hope it's been at least half-what coherent. So what we're going to do now is in this lecture for July 18th, and if you see me tomorrow, I'll be something different, but because I'm just getting this started. But and everyone's got their test back, so that was good. Scores were pretty darn good, so I'm glad we got that taken care of. And I will see you in a while, about 12 days, and on the Tuesday, and I'll have your exam all ready to go. And because we're going to meet for a day. You've had an exam. We're going to meet live for one day, and then you're going to take your other one, and hopefully I can get it turned around just about as quickly as I got this one done, and tie up your grades, and we'll be finished. All right? Okay, so without further ado, let me punch out of here, because once I turn on my ladybug, then the whole thing goes ape because it conflicts with that. All right, so now we've already seen some of this stuff, okay? So don't panic. Let's go to slideshow and let's play from the current slide. So we've done all this stuff, but what I wanted to do is get us to lenses. And here's the lens. And one of the reasons I'm kind of going nuts here a little bit on the lenses and on the eye was I was talking to a student who I'm going to write a letter of rec for, and he had just taken the MCAT and felt like he did pretty well. And I asked him what was on it, and he said a lot of stuff on lenses. It just seemed to, it just seemed to hit him that was what was on lenses. Was there any thin film? No. Well, I asked him, was there any projectile motion? Remember that stuff from Physics 210, which everybody hates? No, not really. Not on the MCAT. But they do sound. Do I do sound? No. So we got to really kind of look at the curriculum a little bit, because we kind of do physics, engineering physics light instead of life sciences physics. And I know that there's a lot of textbooks out there that say, oh, we're the life science. And then you look at it and you go, no, you're not. You're just, you're the same thing. But we need to emphasize like sound and things. The trouble is we just don't have time. If I ran the world, and I'm wasting your time here, if I ran the world, physics would be a 9-hour, or it would be a 12-hour, 3-semester sequence, so that you could get it all. But I'm sure Killer Conway wants the same thing for orgo. I'm sure Goodnev wants the same thing for regular physical chemistry and stuff like that. But how does it feel to want? As we used to say in the Marines. So anyway, here's converging lens. Notice a converging lens, and it's actually called a concave lens too, because we measure the radius of curvature over here for this one, and we measure the radius of curvature over here for this one, and so that is we call that a concave lens or converging lens. And notice the focal length focuses on the other side of the lens, so you get a real image over here. All right, you get a real image over here because the lines actually pass through. Your eyeballs are, this is what you're looking at, all right? So that's where the focal length comes from. All right, notice this diverging lens has a virtual focal length, so it's negative because notice where the axial rays, where the paraxial rays form, they're dotted lines. They come back and they're virtual, and so therefore it is a negative for a diverging lens. Okay, you might want to, I don't really quiz you on this too much. Okay, I don't really quiz you all too much on this, but this was on the MCAT, like what are the different lenses and things like that. Or if you have a plano convex lens, you know, what is the lens maker's equation for it? Why do they do that on the MCAT? Because there's a lot of people that are going into optometry and ophthalmology and things like that. So, which is a great field. All right, so here we go. Here we go. All right, here's your eyeball. Now, you might be going, well, what is this? Well, it's just like your eye. Here, we've got an object that's placed it's on the other side of the lens and is placed over 2 focal lengths away. The real image is inverted and smaller, just like it is in the camera, just like it is on your actual eyeball. We're using this as a lens, which we'll get to in a little while. And then so that's upside down and inverted. Okay. All right. Here's the ray diagrams for. So we got focal lengths on both sides here. All right. I don't know what that's supposed to teach you. Besides being embarrass me because I wasn't quite ready for that. All right. So now look what we have here. Look what we have here. Got an object going through the projector. This is the same type of thing. And we wind up with a real image that's inverted. So that's why the film in a projector is upside down. The pictures are upside down so that it projects a real image that's right side up. Notice the object is small and it's pretty far away from the focal length of the lens. All right. Here's a converging lens. The object is placed between F and the lens. The virtual image is upright and larger than the object. Okay? So this is how a magnifying glass works. Going right over that E, and we're seeing the virtual image back here. Here's the virtual image of the E. Diverging lenses. Shrinks it. Which comes in handy for those of you who are nearsighted. You can see up close just fine, but you can't see far away. We need to bring this object closer to you so that you can see it. And we'll get into that when we talk about glasses, which we'll probably do tomorrow. Here's your thin lens equation and magnification equation. You've seen all this before, right? Okay, you are allowed to bring this to your exam. And you have one on your other slides, you have this one for mirrors also, okay? Where it tells you how to do the problems. So let's do a couple lens problems, and then we might have time to look at the eyeball. I don't think so. I think that's where I'll start tomorrow. Okay? All right.